interfacing LCD to the ARM processor, okay, LPC21. Please remember some basics of LCD we discussed in the last class. So quickly we'll go ahead with that. It's a liquid crystal delay. It's a 16 cross 2 character LCD. It can display 2 lines with 16 character. Each character can be taking a pixel matrix of 5 cross 7. In the diagram you can see A, B, C, D are displayed. A will take 5 cross 7 pixel matrix, or it may take 5 cross 10. How it looks like? So if you see, this is how at the left corner, right corner what I have shown, it looks like this. A will occupy the pixels like this, these many pixels, okay, 5 columns, 7 rows you can say. So similarly it can take 5 columns, 8 rows. So it depends on what kind of LCD you will use. So like this is what the LCD has clearly said: command register, data register. So it means that whenever I want to use command register, I have to give command. Whenever I want to data register, I have to give the data. So who will make us to get into the data register or get into the command register is nothing but RS, register select. If register select is 1, if register select is 0, depending on that the value is passed. You know, VCC, VSS, V are connected respectively to the ground and respectively to the supply, and VE is connected to the potentiometer. And read bar write is very important. If it says, if its value is 0, then LCD is ready to receive. It means write can be done. Write means read, write is equal to 0. So that value pass. If we say enable pin is active, it means that the data is latched on to the register. Otherwise data will not go to the register. Enable pin must be there. So that is what the procedure we have seen. So that is supply, that is the VE. This is what the brightness, VE is for brightness towards positive 5 volts, higher brightness towards negative 5 volts, lower brightness, that will be chosen. And RS is, if RS is 0, command register is chosen. Please remember, RS is 0, command register is chosen. It means that command will go inside. What are the different commands we have? Commands will always be mnemonics. It is mnemonics. Please remember, opcode and operand, how you said, you can call it as opcode. It is a hexadecimal number. Command is given as a hexadecimal number. What are the commands we have? If you remember, 0x38, 0x0c, 0x0f, 0x01. So you just recall, all those things will come across. RS is equal to 0 means command register is chosen. RS is equal to 1 means data register is chosen. So when we say read bar write is 0, it means we are writing the data onto the register which we have chosen. So read by write is equal to 1. Read from the LCD, which is rarely used. Reading from the LCD, rarely used. So enable, if enable pin is high, information is latched onto the register. That is what it indicates. This is how high to low signal when it goes. So it means it gives. For example, it is taken, if I wanted to send a command go to a command register, and then the things has to happen. For choosing a command register, RS should be 0. That's what 0 is chosen. Read bar write should be 0. That's what write is made. So that is what the simple indication 0x38. What this 0x38? This command indicates that the 16 cross 2 lines are active, and 5 cross 7 matrix is used for displaying the characters. That's the meaning. It means that it calls the function. Which function? 0x38 is the command. It calls a particular function just to initialize the 2 lines of LCD, as well as selecting 5 cross 7 matrix or a pixel, what you can call it as. So how it is done, that is the internal program that we are not worried. So that is what the smallest code that do the job. So enable pin, as you said, latching is done. So it means it stores the value. If enable is not active, the value will not be placed onto the register. So these are the different commands. Please remember, if I want to clear the screen, I should give 0x01. If I want to return to home, 0x02, I should pass. These are the commands. Go to command register and does some function. 0x04 means decrement the cursor. 0x06 means increment the cursor. Like this, you please understand all. 0x0a, display off, cursor on. Whichever you want. Display on I want, cursor off I want means 0x0c. Display on, cursor blinking means 0x0e, 0x0f is used. So left shift, right shift can be done. 0x08. That's what some few interesting commands he has clearly shown. which are regularly used, very important. 0x38, last command 0x38, two lines are selected from the display because only two lines are there. 16 cross 2, 5 cross 7 matrix is used for displaying each character. 0 cross 01 indicates clearing the display screen. 0 cross 01 command indicates clearing the display screen. 0x0f indicates display is on, cursor is blinking. 0x06 indicates increment the cursor. If you are incrementing, shift the cursor to the right side, left side on the display. So these commands should be used to do that job. 0x80 displays of on. Are going to write any sort of project with simple commands, nothing much difficult. Just you have to remember these commands, how to pass, how to display the things. 0x80 is very important. Why? 0x080 says that force the cursor to the beginning of the first line, that is 080, first position of the first line. If I wanted to start from some other position, I need to add offset address 080 plus 5, it means 085 it starts. 0xc0, cursor is blinking at the second line, first position, like this. If I wanted to send example data a 65, I'll just force it, I'll enforce it, I'll put all the things. It is a data, that's what rs is. 1, it is read write. 0, it is write. 0 is selected, it means write. Enable is active, latched. What is the value? 0110, 0101, it means 65. 65 is the ASCII value of A, American Standard Code for Information Interchange. ASCII value of A, that is passed to the data register. So A is passed, that's the data. Earlier command passing we have seen, now we have seen the data passing. So like this is what the interfacing we need to do. How to do interfacing? You can choose any port numbers. Here port 0 is used, and for reset and enable P1.20, P1.21 is used. From port 0.122 to 0.19 is used for the data lines T0. That's it. It means that whatever the functionality you want to choose, whatever the data you want to pass from the LPC2148, you need to use the ports and write the code accordingly, so that you are writing onto the port. From the port it goes to display. Display get activated by taking the commands. By using rs, enable and write pins, automatically it gets activated by calling its functions, and then it displays the things according to your program. So let us try to write a program. So we'll just see now. So what is the program? So if I select now, oh sorry, chosen. If we select the program, how the program goes. Now you try to understand, you remember what are the things you remember. You remember the 0x38, 0x01, 0xf0f, 0x0c, 0x06, 0x80, 0xc0. If I say commands, immediately they should come into your mind. Now you try to understand how to write a program. So what is that? The LCD interfacing, as usual, very easy ways. You start with your what is that called as header file, right? Now if you start with hash include LPC2148, what is the common the function call we have, which is nothing but delay. I'm going to call wide delay wide. What extra things with respect to LCD we have?
Sir,
We
screen
need
is
to
not
call the
visible, sir.
function.
Now it
You're
is visible.
sharing. Oh,
Now
yeah,
visible.
nice. Sometimes yeah, it bit delays. Don't worry. Today is the last class with lower internet. Tomorrow onwards, we are going to college. From there, I don't think any problems will happen. Okay.
Okay.
Okay. So LCD underscore init, okay, is the function now is associated with your LCD. Please remember, it will call the function which is called as LCD underscore init. We need to write the functionality of this init function. Init means initialization. LCD initialization. How do you initialize LCD? I should make the LCD on. I should ensure that two lines we are using. I should ensure that I am going to display the character. I'll ensure that I'll start from the beginning. I'll ensure that start from the second line. All those stuffs. So we'll initialize. So for that it is used. Then what is LCD? LCD, as I made two things. I want to pass the command, so I want to use the function LCD command. So what is the command type? It is a type of character or string, whatever you call it as. Command CMD is the term I'll use. Okay, character type. So LCD command I used. LCD underscore data I'll use. If I want to pass the data, so I need to write about data. I want to pass the data. So this is the data. Okay. So a bit late it may come. You just listen to the words also. So wide LCD. Okay. I'll use declaration. What is that? If I want to use string. Okay. So I want to pass the string. So I want to display the string. I'll call the string functionality wherein I'll declare the character which I wanted to display. Okay. So star pointer. I can use the pointer also. You know, in C, pointer is nothing but uh, it's the value taken from the particular address where the pointer is pointing. Here PTR is the pointer variable. It is pointing to the address. When I say star PTR means the meaning is pointer is a address, star PTR value present in that address. You take it like this, very simple. PTR means you take it as an address. Star pointer means value present in that address is nothing but a character. That character has to be passed. So it means I'm just displaying those characters. For that this functionality is required. Very simple. So you start with, so how do you write? So int main, that is what the program you will write always. So what is that? Now any port I can use from the LPC2148 to communicate with the what you can call it as LCD display. So what is that? If I say pincel, if I say pincel 2, if I say pincel 2, what is pincel 2? 0x 0x zeros. So you just observe 0x 8 zeros. Pincel 2 I am using, it means that port 1 I am pointing. Port 0 if I would have used pincel 0 and pincel 1 I would have used port 0. I am pointing now to port 1. When I say port 1, everything becomes 1. So IODIR 1. Please remember in some of the programs they will write different logic, nothing to worry. You can cross compare. There they can use different logics with what is that called as IO pin, IODIR, IO set, IO clear, all four. It depends on the person's ability or the intellect of using different kinds of functions and realizing the task. Here we are following one simple method. Always we are saying that IODIR, IO set, IO clear, and pin selects are sufficient for us to realize any task. Bigger task can be easily realized with the intelligence. That is what we are doing. So IODIR 1, if I declare, so it means that I'm using port 1. Port 1 I'm using. So what is the value I'm passing? You just try to see. 0FFC. 0FFC means what? First, from the right side, if you see, all four are there. 4 zeros means what? Each one is of 4 bits. 4 fours are 16. 16 pins are zeros already. 0 to 15. Total 16 pins. 0 to 15. 16 pins are zeros. Then I I wanted to start. I'm starting now. C I declared. C means 1100. So 1100. Please understand. C means 1100. What is that I'm writing? I'm just passing the value 000 4 zeros, 111 4 ones, 111 4 ones, 1100. Remaining all zeros. 1 2 3 4, 1 2 3, 1 2 3 4, 1 2 3 4. That's it. That means total 18 bits must be there here. If I have not written, you just 17. Total 0 to 17 numbers. 0 to 17 zeros. It means I'm starting with 18. Please understand. I'm starting with 18. That is the meaning. Okay. So I'm starting with P. What is that? 1.18 to P 1.27. You cross check. P 1.18 to 27. 28, 29, 30, 31 are again zeros. So meaning is, what is the meaning? I am using P 1.18 to P 1.25. So total how many bits are there? You cross check. 181920 21 22 23 24 25. Okay, 25 total 8 bits. 25 total 8 bits are assigned to now D0 to initialize, make them output lines D0 to D7. Please remember. So D0 to D7 of what? You have seen the LCD. D0 to D7 of LCD. So similarly, I will write, what is that? P 1.26. P 1.26. I'll assign it to RS. Register select. P 1.27. I'll assign it to whom? Enable. So I'll assign it to enable. That's it. So like this, I have started the program. So you just try to understand now. This is what IODIR is referring to. Why I have chosen F0FFC. I clearly made. Now you just understand. I want to initialize. I want to write the initialization program. So I want to initialize. So while, what is that true? It means that I am into the logic. What is that? If true, so while true, always true. So what is that? LCD underscore. Now I'll make use of CMD. So I wanted to write a command for, see, command and data are sent to the LCD according to the requirement. You see 0x80. Now you look at the chart what I have shown. What is that? 0x80. It means that what it does, 0x80 indicates what? It indicates it initializes the beginning of first line. If you remember, first line, beginning of first line, right? So you write whatever it is. I just, for the clue I have written. So LCD. Once I initialized, I want to display what I want to display. Display with the function, and I'm passing value. Let's say ARM. I am passing the ARM processor. I want to display ARM in first line. Second line I want to display. How to write second line? I need to send the command so that the cursor will come to second line. Command. What command I am passing? So LCD underscore CMD function is for command. LCD underscore data is for passing the data. String is for taking the value and giving it to the LCD. What you can call it as. With that function we are passing. So what is that? 0x C0. If I write C0, not 0C, please remember the difference. 0C is nothing but making the cursor on, and something blinking off. What is that? Sorry, making the display on and blinking off, something like that. 0C. But here C0 means beginning of second line. I am at the beginning of the second line. Okay, so I will display there. What I will do. So I wanted to display the character which is microcontroller. Correct. So that is what I wanted to display. So now this is done. My job is done. What is that I wanted to display? I wanted to display ARM in first line of LCD and microcontroller in second line of LCD. This is what it is required as a function. Now, what are all the additional things required for this? I need to have the defined functionality for init, CMD, data, as well as string functions. That we will do now. The first we know what is the delay. So we started with the delay. So delay, you just practice like this. Delay. What is the delay program? You have int I comma j. You know that. So what is that? For I less than 0, I plus plus, correct? I less than 1000, I'll give, and I plus plus. So this is what. Then what you will do for j is equal to 0. Sorry, I should write 0. I is equal to 0. J is equal to 0. Okay, then j less than 1000, right? You are writing this j plus plus. So this, you know, semicolon is very important. Then closing. So some delay you defined, you can give 2000 or 1000, how much delay you need. Then what else you want? I wanted to declare now, what is this wide init includes? Wide init underscore, sorry, what is that? I should write LCD is the name. Okay, LCD underscore init. So this is, what is that called as wide. Okay, now LCD underscore, I'll write now inside LCD in it. What are the things should be initialized in LCD? LCD underscore CMD. I should give like this. I'm calling that function inside this 0x38. If I say 0x38, what is the meaning? What is the default statement? The default statement is, what is that? Two lines of LCD. Two lines of LCD. Two lines of LCD and 5 cross 7. 5 cross matrix are active, you can say are active, something like this. So LCD underscore, I'll use command again. What is that? CMD 0x 0x 0x. So what is the meaning? What is the meaning? So the meaning is display is on. Please remember, display is on and cursor is off. Correct? Cursor is off. So that is what required. You please write with me. That's good habit for you. So LCD underscore CMD 0x. I'll pass the command 0x01. If I pass like this, so what will be set? After, if anything is wrong, already some default is there. It will be cleared. Clear the screen. So I have in the PPT what I have shared. So you can see that. So this is what the initialization of LED will be done. Now, can you define what is that you want? LCD command, what you want to pass? What is that LCD data you want to pass? So very simple. I'll just tell you the logic. What is that? Here, this logic is followed. Many logics can be written. It is left to you. You can search some other technique you can do. But what we are writing, it is applicable for both lab purpose, in which you need to execute the hardware experiment also. With hardware you need to realize this. That's what we are following one method. Okay, so any different logics can be utilized. So I wanted to clear, I will clear what is that 0x0 FFC. We know this. What is this? It means I have defined P1.18 to P1.27, P1.18 to P1.25 for data, P1.26 is for RS, P1.7 is for enable. That we have defined clearly. So if I clear it, I'll just clear it. So next what happens, we'll see. First I cleared, now I'll reset. Earlier whatever I set, I cleared it. Inside the command what I'm writing, you try to understand. I cleared everything. Now I'll set IO set 1. What I will do, I'll use the command. So what is this command? Please understand. What is this command? CMD. So I will take command. There is some trick which are used always in many programs. Shift CMD left side by 18 bits. It means I am leaving 18 bits. I am leaving 18 bits. Okay, and I am ORing with, please understand, 0x080. Okay, so it means 4 1 2 3 4, so total 8. So what is the meaning? 08 means it will start with 1 0 0 0. 1 0 0 means first 0 is nothing but 4 bits. 4 bits are reserved for 28, 29, 30, 31. But this 8 is telling that 1 0 0 0 means 27 bit is high. Remaining all are zeros. I'm just ORing. When I OR with that, what is the pin which is active? So this indicates that IO set is telling that I am just activating RS pin. That is what this IO command is doing. Please, that's it. Again, I will clear after that. I'll clear 0 0 x 0 FFC. Please remember that. So this is the code. So this function tells that I'm just activating, I'm enabling, or RS pin. You can say RS pin is activated. RS pin activated, you can call it as activated. So here, now if I write wide LCD, that is command. Again, what else if I want to pass the data? What is that data? You just look into. If I wanted to put the data, so I need to send the data, and that data, how see here. So let's write, what is this? The same IO clear, IO set are used. Only thing is the same function. I'm just copying it. I'll just say save. I'll data, I'll replace this by the variable name data. Okay, then it will point to that particular function. So this function we have already declared there. The details of it we are showing here. What is that function? Underscore data. So what we are doing here, 18 instead of C, what I will do is I will pass C instead of 8. If I pass C, it is 1100. 110 means both RS and see here, RS and enable, both RS and enable, and here only RS pin is activated. RS pin is activated means only the command. Here RS enable so that the data is fetched into. Okay, so that is the simple meaning. So these two are very important for activating RS and enable pins. That's what these two are defined. Now I wanted to pass the data. Which data? So that is nothing but your LCD string. LCD underscore string function, we said that through which we are passing the data. What is that data we are giving? We are saying the data from the pointer. Star pointer we are taking. Star pointer, please remember. Star pointer means pointer is pointing to the address, value is taken, that value is passed inside. Once you passed inside, what is that it has? It says that while true, while true, what is that true? While the value of that pointer, okay, what you should do? I should pass with the help of the function data. What is the data? Star pointer ptr plus plus. Okay, so every time I'm passing the value and I'm incrementing, next time again I'll pass. So that is how it will do. So this is where the function string is called. That's it. This is about the program. So please recall all the functions what I have written. Just practice once or twice. This is one logic. There are many logics which you can execute and see. So I'll save it as I'll save as some other file. I'll save as LCD. Okay, so let's say now when you just see this, I want to show first. Let us check this program what it has written is having errors or something like that. Okay, what is this? I have written Mac LCD. Let's say open. Now when I say this, double click on this, so run this. So there are three errors. You cross check. So LCD string has already been defined. LCD underscore CDM. So I'll just check for this. LCD underscore CMD. Okay. So CDM. So it is CMD. Okay. So it will just tell me. And the rest. What is this? LCD underscore string. There is something missing. Where is this? Semicolon missing. Yes, IODIR semicolon missing. Like this. So please rectify. Nothing to worry. So what else? This is missing. Where is this? So int is there. 1 2 1 2. So is that it is telling me. Okay. Okay. So this is what it is. Then I select this. This is correct only. Okay. So now this. Oh, 1 2 2. Okay. 1 2. Let's check again. So I'll save this. Then two errors. One is LCD underscore string. Correct. So string, cross verify. LCD underscore string. Here semicolon missing. That is what it is saying like this. Okay. So then like this. One warning doesn't make any sense. 0 errors. That's it. So this is what the program. Now you just interface this. I'll take the other program which has been already connected. Let's say the same thing. You can see here. What is this? So 1 second. I'll just this one more point. LCD and I'll call LCD. LCD and mbc.c. Let's say. So LCD same thing I have written. You see here. Nothing change. Nothing change. So let's say save. Okay. So what I will do, you can connect, can cross verify. Okay. Your MK is there, warrant problem. So what you will do now? So target you go, set the output, LCD MBC is there, whatever it is you want to call it as LCD. Okay. LCD this LCD only I'll write LCD dot hex file, capitals I have written, dot hex you select, say okay. This process you know. So after this, you just do rebuild, infect, build, and then rebuild. When you say LCD.axf is there, hex file is also created. So with this, I'll come to that point. What is that? So where is it? You cross check now. So I'll just come here. Okay, so this is what it is visible. It will be visible to you within a minute. Wait for it. And then what is that file? I'll say open. I'll say yeah. Yes, something is visible. Pramod, my screen is visible. Quickly, you see.
Yes, sir. With microcontroller and
Yeah.
PCA.
Yeah. So LCD display is there, right? Now you see. Please remember how to select the components. You see here. I will just show you a few points. You just observe here. Nothing more than that, because you already know what to do. For example, what is that? This side, I have a crystal that is common. RST I directly connected to plus 3.3 volts. Separately I can do, and all the remaining can be connected to ground. It's your choice, right? So even RST you can bring through switch. I mean connect through resistor to high voltage and switch to the ground. That also you can do. And trying to avoid the component. That's it. Left side you know what to do. That's a simple way. Okay, this is the default thing what we do. Then right side, come to this. Now you see right side two components are there. What is that? One is LCD. Okay, so another is your relay. So you just check this relay and LCD. Please check this. So what you should do, you just go to the component. Okay, you just go to the component and select for. You please type what is that LCD. Please check this LCD. Which LCD you should choose? 16 cross 2. There is a 16 cross 1 is also there. 16 cross 2. Only one is available, nothing to worry. 16 cross 2 alphanumeric LCD is there. Say OK. When you say OK, you can click here, it will come. See here, when I click this, it will be there. What are the numbers? 1, 2, 3 are there. VSS, VDD, VEE. RS is there, 4, 5, 6. Okay, and then observe D0 to D7 pins are there. You choose D0 to D7. Give the pins numbers accordingly. What is that? P18 to this, 19 to this, 20 to this, 21, 20 to 23, 24, 25. 26 you are giving it to RS. 27 you are giving it to E. Read write is always 0 to write. So that's what you connect it to ground. Read write you connect it to ground. VEE should be connected to relay. VDD should be connected to VDD supply. VSS should be connected to ground. That's it. So you just check now. That is what the connection I made. What is that connection I made? You see here, I have taken relay. So I forgot to say that. What is that relay? You type here again. What is sorry? I'm sorry, not relay. It is pot. You should say pot. Pot. Pot is the potential divider. POT. You pot. Type it. Pot is a device available here. Can you see pot device? Variable register, potentiometer. Say okay. That will come. You click here. That will come. That's it. Paste here. Now how to connect? This pot center line should go to VEE. Center line VEE. Above line is VDD plus 5 volt. Take the supply 5 volt and below line is ground. How to take? You know, go to this. Power is there. Now when I click on this, you can see the positive. Connect this. Double click on this. Type as 5 volts. And ground, you know, take the ground and click here, connect the ground. So that's it. So now VSS you take, connect it to ground point. VDD you take, connect it to positive supply. VEE you take, connect it to potentiometer. That's it. So this is what it is. That's all. Okay. So something I just deleted. You cross check if anything I deleted. This is the supply. Okay, I deleted the VDD line. Okay. So I have to remove this only, this much. Okay. So D, that's it. Nothing I have connected. Where I have connected, you see now. So I just connected. See here. Pin number 18 to D0. D0. You can cross check. D 19, 20, 21, 22, 23, 24, 25. Next 26 I connected to RS pin. 27 I connected to enable pin. Now observe, VSS I connected to ground, VDD I connected to plus 5 volt, VEE I connected to center point. That's it. Now when I execute this, okay, how to execute? I already made there. So what you should do now? So double click on what? Double click on this what is this called as microcontroller. You choose the file. What is the file named? lcd.hex. Choose lcd.x where it is. It will go there only. Take it, say open, and then say okay. 12 megahertz is default is there. Say okay, then run it. When I run this, there is a problem. Due to the complexity of the circuit, it is playing. Can you observe? You just observe it is playing. It is playing. The light coming on and off. You see here, red, blue lights are blinking. Screen of the microcontroller has become yellow. Earlier it was dark. It is doing, but it is unable to display because in simulation it is creating a problem, a burden for the component and the program what we are associated with. It means when I click on these messages, you can see simulation is not running in real time due to excessive CPU load. Excessive CPU load, please understand. Any one of you try to resolve this, it will happen. But this program, what it is executed, is applied to the hardware. That's what I'm not changing the code. It can be easily visualized in hardware in the lab. That's what we are not changing. So what I will do to show this result, we'll bring one more logic. So you try to rectify from your side. If it happens, that's also good. How you can rectify? By simplifying the circuit also, or if your PC is not loaded with any of the CPU load, it means less CPU load, this error can be removed. So some one or two students got this error, CPU load, Pramod, if you remember.
Yes.
Yeah, you can try removing this error again. Load. That is one task I'm giving. Now what I will do is I'll stop this. I will share. I will share now. This code also I'll share with you. Not a problem. You can see this. What is the code? So if you see this code, what is this? MLCD I have written. This code I will share. Now you see this code. This code, he used some extra functionalities for write character, write string. Okay. But this code will not work for our hardware. That for this for simulation purpose you can take. You cross check. Rest of all the things are same. You can see extra while and return because continuously I want to display in the main program. LCD, it includes IO pin logic. Using IO pin IODR, one more logic is written. The same concept, you please go through, and he uses different lines. What lines he uses? Not 18 to 27. He uses these pins, you see. 16 to 17 are for control pins, and port 0 is used for data pins. Port 0.0 to 0.7. Any combination we can use. That's what the logic means. IODIR 0 is used, IODIR 1 is also used. See, some people write IODIR IO1 DIR. IODIR 1 instead of writing IO1 DIR. In many of the logic, this is also followed. IO0 DIR instead of writing IODIR. So both instructions are acceptable. You see, IO0 DIR is used for configuring P0.0 to 0.7. IO1 DIR is used for P 1.16 to 1.7. So this is logic. Some things extra function command has written 0x3c. This function set in 8-bit mode, 2 rows. That is also used. 0f display 06 set input increment mode. 01 clearing the screen. 080 first starting from the first line. So something like this. If this code, I'll anyhow transfer it to you. So what I will do, I'll add this code now. Let's say remove this and add this code. Let's say, what is this? If I add now, what is this code? MLCD. So add, close. Now what I should do, I should save this and run this. So when I compile, 0 error, 0 warnings again, you cross check this code. I'll anyhow transfer it to you. Try to run only for simulation, I'm telling. But this code, we don't want it for hardware realization in the lab when we come to the lab either 2 days or 3 days. That LCD code, what I have written first, will 100% work for hardware. In simulation, you try to work out this, and even that also you can try if you are able to do that. What is that called? A CPU code. Okay. So this one. Now I just executed LCD.exe. I'll just do that now. So where this code is with respect to this. So I'll just change now. Here also the load. Yes, it's coming now. Can you see it? Can you see this now? Pramod?
Sir, I think it is taking some line.
Yes, it is coming now. Just wait for a while. Uh, now
Yes, sir, LED start.
you are sharing it. It's coming, right?
Sir,
The
only
screen is
LCD,
visible now?
sir. Yes, sir.
Yes, correct. Yeah, something. Wait. Now, what I will do, I will just open this and I will open that. What is that? LCD.hex. Say open and then say OK and then run. Are you see something? Yes, Pramod.
No, sir, but it may take some time, sir. There is a lag.
Okay, okay. When it comes, you please tell me.
Okay, sir. Sir, now it came like welcome to telecom department.
Yes, this is what, yeah, correct, correct. This is what exactly you are displaying. In the program, we have written in the first line, welcome to, in the second line, telecom department, and in the first line, we have given some space. In the first line, we have not given some space. It started with welcome to in first line and telecom. This is what the simulation will that load, CPU load, it will come like this only. Full or hardware representation in the lab, that's what we cannot avoid that. Any other logics are there which can definitely display on LCD. So as I said, the program may utilize in program you cross check the pin numbers. You can observe P0.02, P0.7 are connected to D0 to D7. So similarly, P1.1 are used for reset and enable line. So that is how. And the remaining connections, I hope you can observe VSS, VE, and VDD, how they are connected to your port. Okay. So what is used to realize the brightness. That's it. So the logic should be written according to, depending on that, the logic can be utilized. The logic can be written using IO PIR, or only logic can be written with IO. What is that? With port numbers 0, I mean port 0 and port 1 both we can use, or port 1 alone we can use. Logic is left to you. So both codes utilize. I'll try to share that code, whatever we discussed. So each instruction, each line by line, you should know and you should understand accordingly. So we'll stop here. You try to execute this and complete this LCD display experiment associated. Okay. So